Hello, good evening, and thank you for your time tonight. We are here to present today our recommendation for prospect selection in the credit product pilot. And just as a recap, the project scope, we are addressing a business objective that is the following. We want to test the product market fit of a new credit line product for used cars. And there is a challenge, however, and that is that historically, 60% of the customers targeted in the marketing campaign did not accept the product offer. And because these campaigns are rather expensive, we want to address the question, to whom should we direct our marketing efforts to be most effective in this campaign? The data mining task at hand is from a list of 1,000 prospects, to identify the top 100 with the highest probability of accepting the product offer. And our data mining team followed a structured process, including in-depth EDA, cleaning and preparation of the data, including dimension reduction, building, training, and building the model, and test the model for robustness. The agenda of today is the following. We will start with some key insights from exploratory data analysis. We will then discuss briefly the results of the 4 models we tested, and we will finally present you the conclusion and recommendations of this project. So we looked at a large number of variables. We will not discuss all of them, but overall we see that for some variables there's little difference between the acceptor and non-acceptor group, but there are some interesting insights to make. From this slide, I would like to highlight the household insurance and car loan. We know that the acceptor group has a lower percentage of household insurance clients, and we also know that there are less people with a car loan in this group as compared to the non-acceptor group. We also looked at more demographic data. Example would be age. The average acceptor is 42 years old. That's not too far off from the non-acceptor group. There's not much of a difference here. And also gender doesn't matter too much in terms of a likelihood whether they will accept or not accept a product offer. We did see some interesting differences in mean credit balance. The acceptor credit balance is on average $300 higher as compared to the non-acceptor credit balance. So this could be an important indicator for likelihood of accepting the loan. Another interesting observation is that the acceptors were actually contacted less as compared to the non-acceptors, but when they were contacted, the call duration was on average 2.5 times longer than for the non-acceptor group. And this indicates that the salespeople are more effective in closing the deal when they have more time on the phone with the customer. The first model we will now discuss is K nearest neighbors, also known as KNN. And KNN is a classification model that looks at similar cases to classify or to do a probability estimation for an unseen data object. In our case, we look at the classes accept, non-accept of the neighbors of our prospects to assign a probability the prospect will accept the offer. The advantage of this model is that it's pretty straightforward and simple, and we don't have to do a parameter estimation. But the negative, the downside is that it's computationally expensive. So the important parameter in this model is K, the number of neighbors that you will take into consideration to do the classification. And a higher value for K allows for smoothing and reduces the risk of overfitting. But a too high value for K limits the model's ability to capture local structures in the data. That is actually one of the strengths of KNN. When you look at the accuracy for KNN, for different values of K, we see there that accuracy increases with the number of neighbors we include in our model, And for our model, we worked with a K value of 23. And this resulted in a training accuracy of 65% and a validation accuracy of 62%. So there is some overfitting as a result of this model. When we look at the lift chart, we see that we are doing better than just selecting prospects or guessing prospects randomly. And to test the robustness of the model, we decided to run a simulation. So we basically did 10 simulations and took an average of those training accuracies to derive at a final training accuracy of 66% and a final validation accuracy of 61%. So again, the aspect of overfitting is visible in this analysis. I will now hand over the floor to Joe.
Hi, so I'm going to talk a little bit of a regression tree model we use. So the regression tree model goes from observations to conclusion of the target value. The advantage of this model is it's transparent, easy to interpret, highly automated, and robust to outliers. But it could also lead to a problem of overfitting. For data cleaning, we kept all the demographic indicators and removed the variables that are related to contact information. For the generalized linear model tree and decision tree, we have relatively same top indicators as in household insurance, previous attempts, and number of contacts. There are slightly difference between whether people have car loan or what's their age. So it could be depends on the recursive partitioning of the model itself. For the model performance, we have training data accuracy about 67% and validation accuracy about 64%. So it's relatively close. That means we have limited overfitting problem. And for raw curve accuracy, we have overall about 51%, which is not so good because it's only slightly better than randomly selected result. So in my conclusion, I would not really recommend this model. I'll hand over to Wenyu about her random forest model.
Hi everyone, I'd like to talk about the random forest model that we've decided to test as the next model. So we think that random forest model makes sense here because it utilizes the wisdom of the crowd and it works particularly well with large amount of data that has many different variables that potentially can have a nonlinear relationship with outcome. And we've decided to use 100 trees in this case because we think it gives sufficient opportunities to test through different combinations of nodes and tree structures, but do not overwhelm the computing power. So for data cleaning purposes, we are keeping all the demographic data, but we've decided to use this model as a chance to try to include some of the call level data and see if that will be able to improve the model performance. So the training accuracy in this case is around 72% with validation accuracy around 71%. So model actually performed fairly well, and looking at the accuracy matrices provided here, you will see that the model is better at helping to eliminate rejectors than predicting the acceptors, which makes sense, but the difference is very small, works well in both cases. And looking at the lift chart and rock curve, you will see that the area under the rock curve is around 71%, which is in line with our expectation and shows a much superior performance compared to randomly, selecting potential customers. So next page, you will see that looking at the variable importance chart, you'll see there are definitely some call data that are up on the chart, but recent credit card balance and age as well as job type are all pretty important predictors, at least in looking at the results from the random forest model. So the last chart, as you can see, it just shows that we've went through 10 more iterations to test the robustness of the model and accuracy outcome, and it is in line with what we have seen before, showing average training accuracy around 72.5% with average validation accuracy around 70.6%. And now I'll have Joe talk about the model that he was putting together.
Thank you, Wenyu. So the next model we're going to talk about is logistic regression. We decided to do logistic regression because it's a relatively simple and transparent model for predicting probabilities directly. It has a lower impact from multi-collinearity, and it's less likely to be overfit. For the analysis of this data, we only kept the demographic indicators and removed all contact information, since we figured this would not be available for scoring new customers who don't already have a relationship with the bank. To treat the data, we used vtreat, and then we try to boost accuracy using cross-validation. In general, the accuracy was relatively high for this. We have a training accuracy of 76.5% versus a validation accuracy of 74.5%. However, as you can see, it's slightly better at predicting those who won't accept the loan versus those who will, likely because fewer people have accepted the loan in the past, so the model could train itself on fewer data points. This skew is slightly reflected in the ROC curve, although overall AUC was good at 83.7%, likelihood that someone we said would accept the loan did versus chance of 50%. This gave us pretty good lift over chance overall, and our 50th percentile was right at chance. And for the 100th prospect that we scored using this model, they got about a probability of 73.1%. And if we look at what that equates to on a decile-wise lift basis, at that 30th percentile, you get a lift of about 1.5 times over chance, which is pretty good. So in conclusion, logistic regression actually turned out to be the most accurate model, followed by random forest, then regression trees, and KNN. So ultimately, we decided to use logistic regression for our final list of scored customers for both performance factors as well as some other considerations. Most importantly, it had the highest predictive accuracy, but there are other important things to consider is the fact that it has lower computational intensity, is less likely to be overfit. And it's very kind of transparent and easy to explain to individuals, since most people know logistic regression in one form or another, although using vtreat to treat your data obscures the clarity of the variable somewhat. The most important predictors statistically using this model were that in terms of understanding the demographic profile of our potential customers, that they are more likely to be pet purchasers, they work in admin or a blue-collar job, and they do not have homeowners insurance or a car loan. Otherwise, the demographic profile of these top 100 prospects whom we scored were relatively in line with the overall customers of the bank. So thank you very much. We look forward to working with you on this new campaign, and we hope the new loan is a success.